Cambridge Primary Science. 4th grade. Activity book. Electricity and magnetism. 5.1 Electricity flows in circuits. Activity 5.1. You will need a torch with cells. Words to learn. Cell. Flow. Electricity. Current. Complete circuit. Terminal. Investigate a torch. If you turn on the torch, what do you think will happen? Test your prediction. What is inside the torch? What do you think makes the light shine? Be careful of cells. Do not open up. Safety. Any cell, because the chemicals inside will burn you. What is electricity? The torch works because each cell pushes the electricity. This makes the bulb light up. Look at the picture of the inside of the torch. Electricity can flow in one direction. We call this electrical current. You can think of current as particles traveling along a path. In the torch, the current flows from one end of the first cell to the other end. Then it flows through the next cell, through the bulb and back again into the first cell. Current needs a continuous path. This path is called a complete circuit. What are cells? A cell has a positive, plus, and a negative, dash closing parenthesis, terminal. The current flows from the positive terminal to the negative terminal. If you use two cells, you must always put the negative terminal of one cell against the positive terminal of the other cell. Try this out with your torch. Positive terminal, negative terminal. A car battery is a collection of cells. The inside of a torch. The arrows show which way the electric current goes. Questions. 1. What happens if you put the two positive terminals of the cells in a torch together? Will the bulb light up? 2. Explain why the cells in a torch have to be arranged with the negative terminal of one cell against the positive terminal of the other cell. What you have learnt. A cell pushes electric current around a circuit. Electric current flows from the positive to the negative end of a cell. Talk about it. What things do you use that need cells? You can think of current as particles flowing round the circuit. Bulb. Cell. 5.2 Components and a simple circuit. Components. The bulb and the cell in a torch are each a component of a circuit. Words to learn. Component. You may have used these electrical components in stage 2. Break. Plus. Each cell has a positive terminal, plus, and a negative terminal, dash closing parenthesis, dot. A bulb or lamp. A bulb holder. Copper wire covered in plastic. Activity 5.2. Making a simple circuit. Cut the wire to make two lengths of 15 centimeters. Strip the plastic coating from the ends of the wires with the knife or wire strippers until 2 centimeters is bare at all ends. Look at the diagram. Predict what will happen to the bulb in this circuit. Make a circuit with one cell and you will need a cell, a bulb in a bulb holder, wire scissors or wire cutters, a knife or wire strippers, tape, 3mm screwdriver. Be careful with the knife. Always strip away. Safety. From you. One bulb as shown in the diagram. Observe the bulb. Predict what will happen to the bulb if you break the circuit by removing the tape and wire from one end of the cell. Now break the circuit. Observe the bulb. Questions. 1. What happened to the bulb in your completed circuit? Explain why this happened. 2. What happened to the bulb when you broke the circuit? Explain why this happened. What you have learnt. A simple circuit is made up of components such as wire, a bulb and a cell. Talk about it. What would happen if you added another bulb to your circuit? 5.3 Switches. Words to learn. Switch. Serena turns on the light switch. The switch closes the circuit and the light shines. When she turns off the switch, the circuit breaks and the light goes off. A switch is another component in an electrical circuit. The switch turns the electric current on or off. It is the same idea as turning a tap on or off. The circuit you made in activity 5.2 had no switch. To break the circuit, you took the taped wire off one of the cell terminals. A switch lets you turn a bulb on and off when you like, without having to break wires. Activity 5.3 Making a switch. Put together the parts as shown. Strip the plastic off the ends of the two pieces. Paper clip. You will need a small block of wood, 2 metal drawing pins, wire, a sharp knife, a metal paper clip. Drawing pin of wire. Wind one end of each piece of wire round the drawing pins as shown. Wood. Press the paper clip down until it touches the other drawing pin. This completes the circuit. To switch off, lift the paper clip off the drawing pin. This breaks the circuit. Activity 5.3b. Making a circuit with a switch. Make a circuit like the one shown. Predict what will happen when you close the switch. Close the switch. Observe the bulb. What happens? You will need a switch, a cell, a bulb in a bulb holder, 30 centimeters wire, a sharp knife, scissors. If the bulb does not light up, check all your connections in the circuit. Try again. Questions. Why does the bulb light up when you close the switch? 2. What must you do with the switch to break the circuit? 3. Draw the circuit you made. Label the cell, the wire, the switch, the bulb and the bulb holder. Why did you need to check your connections if the bulb did not light up? What you have learned. Closing a switch completes a circuit and allows electric current to flow. Opening the switch breaks the circuit. This means the current will not flow. Talk about it. Where are switches used on electrical devices that you have seen? 5.4 Circuits with more components. Activity 5.4. Making a circuit with more components. So far you have made a circuit with one bulb and one cell. You will need 2 cells, 3 bulbs in bulb holders, a switch wire, sharp knife, scissors, tape, elastic band, a stick. Use tape to join 2 cells together to make a stronger cell. Make sure the positive and negative terminals are next to each other. Elastic band. Use the scissors to cut the wire into short lengths. Complete your circuit using 3 bulbs in bulb holders as shown. Close the switch. Observe the bulbs. Open the switch. Stick tape. Remove 1 bulb and a bulb holder so that only 2 bulbs are left in your circuit. Predict what would happen if you remove 1 more bulb in a bulb holder. This means that only 1 bulb remains in your circuit. Test your prediction. What happens to your bulb? Questions. 2. 1. Did the bulbs shine more brightly or less brightly when 1 bulb from the circuit? Why do you think this happened? Removed. 2. What happened when you only used 1 bulb in the circuit? Why do you think this happened? 3. Describe the path of the electricity in the circuit you made. What you have learned. The bulbs shine less brightly when you add more bulbs to the circuit. If you have too many cells in the circuit, the bulbs pop or burn out. Talk about it. Why may bulbs not light up in a circuit? 5.5 Circuits with buzzers. In activity 5.4, you left just 1 bulb in your circuit. The bulb probably popped or burnt out. This was because the source of electricity was too strong for 1 bulb. Words to learn. Buzzer. Voltage. Different components need different strengths of electricity. A buzzer is another component of a circuit. It needs a stronger supply of electricity than a bulb. The strength of electricity is measured in a unit called a volt. V. Dot. The strength of electricity that a component needs for it to work is called the voltage. Volt. Size R6. Size R6. 10. 2100 milliamperes. 2100 milliamperes. These cells have a strength of 1.5 V. This buzzer needs a supply of 3 volts to work. This bulb needs a supply of 1.5 volts to work. Activity 5.5. Making a circuit with a buzzer. If you put a 3 volts buzzer into a circuit, you need a 3 volt cell to make the buzzer work. You can make a 3 volt supply by joining two 1.5 volt cells. You will need 3 1.5 volt cells, a 3 volts buzzer, switch wire, a knife, scissors, tape, elastic band, a stick. Check on the side of the buzzer to see which side is positive, plus, and which side is negative. Dash closing parenthesis. Dot. Connect the buzzer in the circuit so that the plus terminal is connected to the dash closing parenthesis terminal of the cell. Set up your circuit like the one shown in the picture. Test your circuit. Does the buzzer make a noise when you close the switch? Take away one of the cells. Test your circuit again. Add 2 cells. Now your circuit has 3 cells. Test your circuit again. Questions. 1. How well did the buzzer work when you had 3 cells in the circuit? 2. How well did the buzzer work when you had 1 cell in the circuit? 3. Why do you need at least 3 volts to make the buzzer work in your circuit? 4. You want to run an electric toy that has a voltage of 6 V. Why won't it work properly when you use a 1.5 volt cell? What you have learned: components such as bulbs and buzzers need a certain strength of electricity to be able to work. The voltage is the strength of the electricity. The cell must have a strong enough voltage for the components in the circuit to work. Talk about it. What things do you use that need more than 1 cell? 5.6 Mains electricity. So far you have been using cells and components with voltages between 1.5 volts and 3 volts. These are safe to use. At home we have mains electricity. Words to learn: mains electricity, appliance, wall socket, copper, electric shock, overload. This uses a much higher voltage, over 100 volts. The exact voltage depends on your country. We use mains electricity for lights. We also use mains electricity to power an electrical appliance. Appliances must be plugged into a wall socket. Always turn a switch off before you take out a plug. The lights in Hong Kong use a lot of electricity. Safety rules. If mains electricity flows through your body, you will get an electric shock. Mains electricity can also cause a fire if the plastic wears off the copper wires. Electricity is only dangerous if you don't use it properly. Never push anything, especially your fingers or a metal object, into a wall socket. You could get an electric shock. Dry your hair outside the bathroom. Never use electrical appliances when your hands are wet or when you are in the bath. You could easily get an electric shock. We can use mains electricity to charge new electric cars. Look at the picture of the Mbatha family's kitchen. Do not plug too many appliances into one socket. They will overload the socket and cause a fire. Questions. 1. Why should Thabo's mother dry her hands before she plugs in the toaster? 2. What is Thabo doing wrong at the wall socket? 3. Why is the wall socket behind the iron dangerous? What you have learnt. Mains electricity has a much stronger voltage than the electricity from cells. Never handle electrical appliances when you are wet. Follow the safety rules when using electricity. Talk about it. What dangerous uses of electricity have you seen? 5.7 Magnets in everyday life. Pedro is helping his grandmother pick up pins. Words to learn. Bar magnet, wand magnet, horseshoe magnet. Evidence. Is doing it the easy way. He is using a bar magnet. Keeper. A magnet attracts some materials to it. We call these materials magnetic. Types of magnet. Magnets come in many different shapes and sizes. A horseshoe magnet is shaped like a horseshoe. A wand magnet is shaped like a wand. Some magnets are disc-shaped. Some magnets are shaped like rings. Activity 5.7. Finding out which materials are magnetic. You will need a magnet, some materials to test. Choose at least 6 things to test, for example, buttons and paper clips. Plan a test to see which things are made from a magnetic material. Carry out your test. Record your results in a table. Are all materials magnetic? Use the evidence you have collected to answer this question. Looking after magnets. Magnets lose their strength if you damage them. Make sure you don't drop them or bang them together. Store them in a box and cover the ends with a keeper. Use a keeper to keep magnets strong. Lots of things we use every day have magnets inside them. The magnets attract metal parts and keep them in place. There are magnetics inside a television. Questions. 1. Name 3 different types of magnet. 2. Why should you not drop a magnet? What you have learned. A magnet attracts some metal objects to it. These objects are magnetic. Objects not attracted to a magnet are non-magnetic. Talk about it. What things do you have at home that contain magnets? 5.8 Magnetic poles. Magnets have magnetic poles, called the North Pole and the South Pole. For example, on your bar magnets, the red end. Words to learn: North Pole. Poles. South Pole repel. Is the North Pole and the blue end is the South Pole. Attraction and repulsion are magnetic forces. These magnets push away from each other. We call this repulsion. Activity 5.8. Investigating bar magnets. Unlike poles pull towards each other. We call this attraction. Your magnets have ends marked in different colors. You will need 2 bars magnets, string, scissors, such as red and blue. Tie a piece of string round the middle of each bar magnet. Hold the end of a string in each hand so that the magnets swing. When the magnets stop swinging, bring one magnet close to the other. Make sure that the end of one magnet faces the differently colored end of the other magnet. What happens to the magnets? Hold the magnets so that 2 ends of the same color face each other. What happens to the magnets? Predict what will happen if you hold the magnets with the other 2 ends of the same color facing each other. Test your prediction. Repeat this a few times to check your prediction. Activity 5.8b. Identifying the poles on a horseshoe magnet. The poles on your horseshoe magnet are not marked. You can use a bar magnet to identify which end is the North Pole and which is the South Pole. Plan how you will do this. Now carry out your test. Like poles push away from each other. They repel each other. You will need a horseshoe magnet, a bar magnet. Questions. 1. How did you carry out the test? 2. How did you decide which is the North Pole and which is the South Pole? 3. Draw the horseshoe magnet and label the poles North and South. What you have learned: magnets have a North Pole and a South Pole. Unlike poles attract and like poles repel each other. Attraction and repulsion are magnetic forces. Talk about it. Are a magnetic's North and South poles the same as the Earth's North and South poles? 5.9 Strength of magnets. Activity 5.9. Testing the strength of magnets. Place the paper clip at the O end of your ruler. You will need 3 different magnets, a metal paper clip, a ruler. Place the North Pole of magnet 1 at the other end of your ruler. Slowly move your magnet towards the paperclip. N 4 6 1 0 1 1 1 2 1 3 1 4 1 5 O S. Stop the magnet as soon as the paperclip is attracted to and touches the magnet. Read off the distance in mm on the ruler. This is the first reading. 2 4 5 6 0 N S 1 0 1 1 1 2 1 3 1 4 1 5. Now find a second reading for the North Pole of magnet 1. Now carry out the activity with the South Pole of magnet 1. Present your results in a table. Repeat the activity to test the strength of your other two magnets. Calculate the mean readings and fill in the mean reading column of the table. To do this, you add together the first and second readings, and then divide the sum of the readings by 2. For example, if the first reading is 6 mm and the second reading is 8 mm, the sum is 14 mm and the mean reading is 14 mm divided by 2 equals 7 mm. Draw a bar chart to present your results. Use the mean readings. Questions. 1. Were the two measurements for each magnet always the same? 2. Why is it good scientific practice to make each measurement twice? 3. Were the strengths of the north and south poles of each magnet different or the same? 4. Did the steps you followed make a fair test? Why or why not? Challenge. Why do we need magnets that have different strengths? What you have learned: magnets have different strengths. Some magnets are stronger than others. Talk about it. How else could you test the strength of magnets? 5.10 Which metals are magnetic? Some metals are precious, such as silver, gold, and platinum. These metals are expensive. Metals that we use in everyday life are iron. Words to learn: silver, alloy, steel, aluminium, copper, and chromium. Often things are made from a mixture of metals. A mixture of metals is called an alloy. Steel pipes. Cast iron cook pots. Iron is used to make machines and cast iron cooking pots. Steel is an alloy made mainly from iron. It is much stronger than iron. We use steel to make machines, steel pipes, and bridges. Aluminium is light in weight and does not rust. We use aluminium to make pans for cooking, aluminium foil, and to build aeroplanes. Cans for cold drinks are also made of aluminium. Aeroplane. Copper wire. Chromium is mixed with steel to make an alloy called stainless steel. Stainless steel. Stainless steel cutlery. Does not rust. It has many uses such as knives, sinks, and medical instruments. Brass door handle. Copper is used to make electric cables and wires. Brass is an alloy of copper and zinc. We use brass to make door handles. Activity 5.10. Are all metals magnetic? Predict which objects you think will be magnetic. Test your prediction. Hold the magnet next to each of the metal objects. Observe whether the metal is magnetic or not. Record your results in a table. Questions. 1. Name 2 magnetic metals. 2. Name 2 non-magnetic metals. 3. Give 3 examples of things you use at home that are made of metals. Which metals are they made from? Are these things magnetic or not? 4. How does the magnet separate iron and steel from other metals? You will need a magnet. Black circle a selection of things made from different metals. The magnets attract metal cans made from iron and steel and separate them from the rest of the rubbish. Then the cans are recycled. What you have learnt. We use metals in everyday life. Mixtures of metals are called alloys. An example is brass. Iron and steel are magnetic. Many other metals are non-magnetic. Talk about it. How can you use magnets to sort steel and aluminium? Cans. 5. Check your progress. 2. Write one word that each of the following describes. A. Something that pushes electricity round a circuit. B. The strength of electricity. C. The flow of electricity. Which of these are magnetic and which are non-magnetic? Wood. Copper, steel, plastic, aluminium. Iron. A. Name 2 components of an electric circuit. B. Name 2 types of magnet. C. Name 2 industrial uses of magnets. 4. In the circuit below. A. What is the function of the component marked A? B. Is the current flowing clockwise or anti-clockwise? C. If you added a second bulb in a bulb holder, would the bulbs glow more brightly or less brightly? D. If you added 2 more 1.5 volt cells, what could happen to the bulbs? 5, 6, 7, A 1.5 volt cell is used with a 3 volts buzzer. Will the buzzer work? Explain your answer. Which of these statements are true and which are false? A. You must never push anything into a wall socket. B. It is safe to use an electrical appliance in a bathroom. C. An electrical socket can have as many appliances as you like plugged into it. Why does using a magnet help to pick up pins? 8. Describe how you could test the strength of magnets. Reference. How to use a thermometer to measure air temperature. 100, 90, 80, 70, 60, 50, 40, 30, 20, 10, 0 to 10. Hold the thermometer at the top. Put your eye level with the top of the liquid in the thermometer to read the scale. Do not hold the bulb as the thermometer will measure the temperature of your fingers. How to use a thermometer to measure the temperature of a liquid. 100, 90, 80, 70, 60, 50, 40, 30, -20, -10. Hold the thermometer at the top. Wait until the thermometer reading stops changing. Read the scale before you take the thermometer out of the liquid. Put your eye level with the top of the liquid in the thermometer to read the scale. Make sure all of the bulb is in the liquid. This liquid is at 43 degrees Celsius. How to use a stopwatch to measure time. Find the start, stop, and reset buttons on the stopwatch. Check you can start, stop, and reset the stopwatch. Watch to see which digits count the seconds. The two smaller digits count hundredths of a second. 00, 0000. Drisha and Idra are timing how long ice takes to melt. The ice in the sun melted in just over 3 minutes and 35 seconds. The ice in the shade melted in 5 minutes 48 and a half seconds. 03, 35, 04, 05, 48, 50. How to plan a fair test. To plan a fair test, you must only change one variable in the test. All other variables must be kept the same. Suk and Pembe are investigating which materials are better at stopping sound. I meter. CECCTCTCTCTTTC. The variable they are changing is the material being used. To keep the test fair, Pembe must hold the materials the same way each time. Suk must also keep the loudness of the triangle the same. The distance from Pembe's ears to the triangle should also be the same. How to design a bar chart. Olga and Sam have been counting the living things they find in the garden. They have made a tally chart to show how many of each sort they have found. Birds, worms, ants. Number of living things found. Pipe, spiders. 0, ####, ++. They want to draw a bar chart on squared paper. First, they have to draw the axes for the chart using a ruler. To decide how tall to make the y-axis, they look at how tall the bars will be. They saw 12 ants, so the tallest bar will go up to 12 on the y-axis. 12. A y-axis at 12 because there are 12 ants. Number of living things, 42 OA. 10. 8 y-axis. There is no bar for worms as no worms were found. 4 bars on the x-axis, bars drawn carefully using a ruler x-axis.